talk the symbols for a minute. You had before sample and population. So far we did a sample mean, we did a population mean. We used your sample and your sample information to make an inference about your population mean. We did it in the z-score, we did it in the t-score. This little section uses a proportion. Your proportion for your population is going to be P. That's going to represent your population proportion. Your proportion for your sample is going to be P with this little thing above it. We call it P hat. It looks like P is wearing a hat. So your sample will be P hat. Put this on your notes if it's not there. And your population will be what's plain old P. We make an inference about this based on whatever we find in your sample. Same situation as we did before. Everything else is going to work pretty much the same. And this one, whenever we need a ZC or TC, we use a Z. Okay, and now, all this is asking us is to find a proportion. And a proportion is usually a part over a whole. So we've got to look for something that we can set apart over a whole. Once we find a P hat, we can find a Q hat by 1 minus the P hat. Okay? We call these things hats. So simple enough, we come to the first example and we say, out of 1,000 U.S. teens, do you think this is a sample or a population? 1,000 U.S. teens. Sample, because aren't there lots more teens in the United States? So we've got a sample. 372 said they own smartphones. Find a point estimate for your population proportion. Find the point estimate means I'm finding the proportion for my sample. The reason we say for the population is because this is what's going to represent the population. We're going to make an inference on our population based on what we found in your sample. We do part over whole. So out of 1,000 U.S. teenagers, 372 said they own a smartphone. Just set it up like this, and so therefore 0.372. This is your P hat. To find Q hat, you're doing 1 minus this. This is your Q hat. Oops. 1 minus this. This is your Q hat. So Q hat would be what? 8.618. 28. 0.628. So that's how tough this is. That's all we're doing. And the rest is probably going to fall into place. It'll look just like your z-scores. So if you're given, and what you have to make sure is that you realize you're using your proportion from your sample to make an inference about your population. So if I surveyed 2,462 U.S. teachers, of which there are probably many, many more, right? So this is a sample. 123 of those surveyed said that all or almost all of the information they find on using search engines online is accurate or trustworthy. Not a lot of people, is it? So the majority are saying that it's not trustworthy. But our P hat says part over whole. 123 over 2462. How do I convert this to a decimal? How do I get a decimal out of that? Divide. Divide it. God bless you. God bless you. So only 5% of this sample said that they find this information trustworthy or useful. So what would the Q hat be? question. 0.95. Okay, if P hat is 0.5, what is Q hat? If P hat is 0.05, what is Q hat? 0.95. Make sure we know there's a difference when we move the decimal. Okay? So that's how difficult this is going to be, making a proportion. Now, to construct a confidence interval, same way we did before. Before we did the sample mean plus or minus the margin of error. Well, this time we do the sample proportion plus or minus the margin of error. We're making the inference about your population. In other words, if I sampled those 1,000 U.S. teens, and I found that 372 of them said yes, whatever they said yes to. I forgot what it was, but I remember the numbers. Whatever I find is what I'm going to infer about all U.S. teens based on that sample. So I want to be confident that I'm getting within that proportion. Now, you notice when you divided them, you're getting decimals. So your proportions are going to be decimals. If we move the decimal place 2 places, it's a percent. So your proportions are going to be decimals. The only thing we have to change here is your margin of error, of course. But we do use a ZC. We use the Z-score associated with this. So if it's 95, we're going to still do inverse norm. We're going to find your ZC in inverse norm. We're going to use your P hat, your Q hat, and your N. Okay, Q hat you're going to find. P hat you're going to find by proportion, then you're going to subtract it from 1. The rest is about the same. So again, you're going to identify your statistics. You're going to find your P hat. You can find your Q hat. We're going to have to verify. Notice that we're asking, this is kind of like that binomial thing. We're asking yes, no, yes, no, 2 choices. We're going to have to verify that it matches, that it can approximate a normal distribution. Otherwise, we don't know that it approximates a normal distribution. We're going to again find your ZC. We know how to do that. We're going to find your margin of error. We just have a new margin of error formula. And we're going to build your interval. Sound good? Questions? I gave you notes. Embellish your notes. Yes?
Will there ever be a question for standard error?
The standard error as a mean? Such as what?
Like it just says give us the standard error, which is a sigma.
That's your margin of error.
No, that's not margin. It's more.
Oh, that's your margin of error.
So
For your population? No, I'm not going to do that. Don't worry about that one. Yeah. I wouldn't know. We're just building your intervals right now.
And it also says that the sample distribution of P hat is equals to mu. So if we want to find the mean, it would be C. Not really. So does that mean the percentage?
Well, remember when you did n times k was your mean?
Oh, okay.
That's what they're talking about here, n times k.
That's it.
That's how you found your mean before. Because we did, remember in your binomial thing, we didn't have a way to find it?
Mm-hmm.
So don't confuse that yet. I just want you to symbol to the intervals yet.
Okay.
They kind of go a roundabout way about this. Yeah, that's because your old formulas were u equals n times k, then the standard deviation was the square root of those guys. Okay, so let's start real simple. We're going to construct a 95% confidence interval for the population of teens who own the smartphones. So we asked 1,000 teens, and we're going to say X. This is how many responded yes. Was it 372? From example 1. 372 responded yes, they owned a smartphone. So we found their P hat. It based it on 1,000, so it made our decimal points nice. We found our Q hat. Okay? Now, all we have to do is build your confidence interval. Your confidence interval is p hat plus or minus 8. Your margin of error says we're going to find your ZC. We know what your confidence interval is, 0.95. We're going to multiply this by the square root of p hat q hat over n. So how do we find the ZC for our 95% confidence interval? How do we do that? How do we do that on your calculator? Inverse norm. Inverse norm. We tell it 1 minus parentheses 0.95 divide by 2. 95% of it's in the middle. They're going to share 5%. If they share 5%, we divide it by 2, 0.025. So we're letting the calculator do it for us. We're coming down and pasting. We're going to take the positive value. So 1.96. We put p hat and q hat in here. 372.372 times 0.628. Divide by, how many was in my samples? With n? 1,000. So, put this in your calculator and find me a margin of error. Once you put your square root sign, you don't need any other parentheses. You can do this times this, divide by this. And order of operations will work. So what did we get? Good. 0.03. Now these are all proportions, right? So shouldn't I be looking at decimals? I should be looking at decimals. If I move this over, 3%. If I move this over, 37%. So to build this, you're just taking your p hat plus or minus your 0.03. You leave it in decimals. It makes more sense, and at the end, if you want to flip it, you can, but it makes more sense this way. So you're going to get 0.342 to 0.402. Now, again, this means this. P for my population, this means that I am 95% confident that the population proportion of teens who own smartphones make sure you know how to say this, is between 0.342 and 0.402. Or it probably makes more sense to say 34.2% and 40.2%. I need to be 95% confident that the population, I know the sample does, we just found the sample. We put the sample in the middle. But I'm making this inference about the population. Actually, I think this one kind of does it a little bit better, because I think a lot of you are struggling when you use just a little comment in between. Now, your calculator has a really nice step for this as well. If you take a look at stat, you go to test, I'm looking for an interval, but I don't have a z. Well, I'm going to use a z, but I don't have this here. This is not looking right to me yet. Oh, look at this. A proportion that uses a z-score interval. There I am. One proportion, z. I need a z for my interval. Interval. It kind of just cut the word off, interval. But you see what we're looking for? One proportion, z interval. When you do this, this is how nice this is. You put your x in. You put your n in. You put your confidence interval in. And that's it. That's all the information that they give you. You calculate. Notice it returns you back your p hat. It does the x divided by n for you. And for those of you that like the calculator and didn't use the margin of error formula, you can subtract this guy from here and get your margin of error. Same as we did the other ones. So the biggest part is recognizing this. It's an interval, it's one proportion, and it uses a z-score. One proportion z interval. If you went to the z by accident, you'd have no x and no n to put in there. So this is a nice calculator step to be able to use. I love the intervals on the calculator. Okay? Alright, so you guys are going to try this next one. If I get it. You guys are going to try this.
So instead of the sample saying that calculate between these two samples for the interval, let's say calculate for these two percentages of success.
Well, they're not exactly saying, so what they're saying is this. You did a survey. You surveyed 1,000 teenagers. You found that 37% of them, 37.2% owned a smartphone. Now, those 1,000 teenagers should represent my proportion, my population proportion. So I should say out of all the U.S. teens, 37.2% own a smartphone. Now, that means I have to hit 37.2 right on the nose. So instead, bless you, I play with a little wiggle room. I say, okay, give me a little plus or minus here. So now I can say between 34.2% and 40.2%. My population, my actual population should fall between these two. Don't I have a better chance of getting between two numbers rather than hitting 37.2 right on the nose? I mean, it's your wiggle room. The best wiggle room you get is right, they do proportions for your polling. Your polling comes out in proportions. Hillary Clinton is 37 percentage points ahead, 37% ahead of, I'm just making this up, plus or minus 3 percentage points. So at any given time, Hillary Clinton, plus or minus 3, these are proportions. This is where your polling comes from. She could be from 34% to 40% of the population could be voting for her. If I'm going to look at the whole population. All these polling things really come into play in this. And one of the... Yes? So what's your margin of error for this guy? And so my margin of error would be...
That's not try it one.
Oh, this is not try it one?
I mean, like, the question is...
Oh, oh, my mistake. So let's step back a second. Let's not do their try it two yet. Let's do the other one for 90%. I thought we were doing the same one. Sorry. Find me your margin of error for this guy. Good call on that, Jared. I wasn't even reading that. We'll do this one next. So we get 0.025. That is going to round to 0.03. I get it. But because they're so similar, we'll use the 0.025. So your p hat was 0.372 plus or minus 0.025 versus 0.030. So our 95 is going to be a little bit wider than our 90, right? They look like they're the same, but they're a little bit wider. All right, and we don't have to do that one. I would rather see you do the difference between the same as these. Okay. All right. You guys do this one. Miss Yo-Yo? Put your phone away. All right, everybody try example 3. Let's use your calculator and let's use your formulas. All right, so we need an E. We know our N, we know everything else. So E. So what is the ZC associated with the 0.99? 2.58, 2.575. N, we know the N. They got to tell us N. Sometimes they don't tell you in the problem, but they tell you in the diagram. So you got to have to look for those sometimes. So what does my margin of error become? 0.052. Thank you. Okay, so we take your p hat, which is 0.71, plus or minus 0.052. If you made it 0.05, that's fine too. And you'll get your confidence interval of 0.658 to 0.7. Now, when we look at this, we say, here's your proportion, yes, 0.71, but you were telling me that about 71% of adults think teenagers are the most dangerous out of this sample of 498 people. So if I want to know what the whole United States thinks about who's the most dangerous, I'm going to have to say 71% of all U.S. adults think that. Well, for me to hit that exact number, 71, is tough. So I give myself a room for error, my margin of error room. I add and subtract it. So now I'm going to say anywhere from 65.8% to 76.2%. I can be 95%, 99% confident that the population proportion, or percent in this case, will be between 65.8 and 76.2% that think teenagers are the most dangerous. So that gives me a little bit more wiggle room in there, rather than guessing one number. But the rest of it's not changing. Everything else is pretty much staying the same. It's only Tuesday. You guys are all falling asleep on me here. You have an excuse. You're the only one that has an excuse, Nick. So let's put this on your calculator. So, stat, test. Now I'm looking for a proportion that uses a Z interval. There I am. X, what did you say X was? 354? Thank you. 355?
Yeah, good.
4? Okay, N was 498?
Yeah.
Your confidence interval, look how nice this is. Okay, now, there's your interval, and they give you your p-hat. You don't even have to calculate it. Well, they did give it to us. If you subtract it from this guy, you will find your 0.05. You will get your margin of error. Okay? Looking good. All right.